Hi everyone, welcome to the Dapr 1.15 celebration event. I'm Mark Duiker, developer advocate at Diagrid and one of the Dapr community managers. And with me is the CEO of Diagrid and Dapr co-creator, Mark Vossel. Welcome, Mark.
Thanks, Mark. It's fantastic to be here today. It's super exciting to show what we're going to come across.
So today it's all about Dapr 1.15 and the graduation. And this is the agenda that we're doing now. So first we're going to talk about the Dapr graduation because it's been quite a big year for Dapr this year. Next up is the workflow API. Then we'll talk about the jobs API and scheduler service. We'll talk about streaming subscriptions, in particular with the Python SDK. We're going to talk about error codes in metrics and also resiliency policies based on status codes and error codes. Also, all of it is brand new. The very new conversation API with a .NET demo there. And of course, we give some information how to upgrade to the 1.15 version. And we'll end with a Lego giveaway. So I think it's time for the first session. And by the way, if you have any questions, put them in the chat or in the Q&A option here in Zoom. And we're going to start with you, Mark. You're going to share a bit about the Dapr graduation process.
Yes. If you move to the next slide, yes. I mean, if you've missed the news, but Dapr graduated into a CNCF, and it's the highest accolade that you can achieve. It's an amazing contribution. You can see these incredible stats here across the project. And really, more than anything, across its long journey, it reflects not only the excitement inside the project, but also all the contributions from the community. I mean, we could not have done this without all the community being behind the project, supporting it, being part of the journey on the way. And so you'll see here that Jeroen and I created a little video. There's a little reflection on looking back over the project. If you follow that blog link below there, you can sort of hear about our thoughts. And it's a fun little video where we sort of reflect on what the project's journey was, how it got here, some of the exciting things on the way. So, please go and, go to the blog post, listen to the video. It's only a 10-minute video, but it kind of gives, kind of an idea of how the project started and sort of the exciting points on its journey. And if you look at its journey, on the next slide, you'll see that, Dapr has taken a 6-year journey to achieve where it is today. We first created the idea of Dapr back in the beginning of 2019. And that was born out of a lot of the pain points that we saw for developers struggling to build these distributed applications at scale and running them on platforms like Kubernetes. And then over that year, we iterated, and I think that time, up until the February 2021 release, it was a super exciting time where the community got behind creating lots and lots of the components. We released it with 6 APIs. I always remember the secrets API was one of the community contributions as part of this. And then soon after the 1.0 release, we started to formulate the project a lot more in terms of creating a steering and technical committee, and then submitted it into CNCF straight as an incubation project. In fact, it was one of the first projects to go straight into incubation phase. And then, now over the last 3 years, as it's been inside CNCF, we've had many iterations. We've gone through adding lots of other APIs, including workflow API. And now, as we sit here in the 1.15 release that's coming up, we're super excited to have all of the components that have been added to it over the years, the APIs, the community contributions, and of course, achieving CNCF graduation. And graduation is an incredibly important thing. You can read the CNCF announcement below here, and it dives into some great quotes and background stories, and importantly, quotes from end users who have built thousands and thousands of applications on Dapr, and the thousands of organizations that use Dapr. And if you move to the next slide, you'll see here, the process was actually pretty involved. We first put the submission in last year, and then CNCF goes through a due diligence process where they look at the project in scrutiny across all different aspects, the contributions to the project, the end users, the governance inside it all, the community contributions, the fact that we have great documentation around it all, and they really dive into it all. So, it's not to be taken lightly in any way. And so we're incredibly proud. And for all of those of you who upvoted the project, made or contributed in any way, we just thank you enormously, because we could not have done this in any way without the amazing help of the community and everyone behind it all. And so now we're amongst the list of all of the other graduated projects inside CNCF. And you see here, we're very proud that the project is here, and it really speaks to the testament of the community and everything else about it. So thank you if you contributed, and let's follow us, continue us on the journey for the next 6 years.
Yeah, that's really cool to hear, Mark. And yeah, especially indeed, I actually didn't realize we actually skipped the first CNCF level actually and went straight into incubation.
And straight to incubation. It was, yes. I mean, that's just because the acceleration of the project at the time and the end users were enabled us to do that, who took a dependency on the project.
Very nice, very nice. Yeah, and I've witnessed the need, the whole process need from yeah, quite close by, and yeah, it was amazing indeed, seeing all the people contribute and make all the improvements and seeing all the end user interviews happening. Yeah, it's quite impressive to see. So also very happy and proud that we're here. Excellent.
Yeah. So with that, let's kind of dive into now the rest of what we're doing inside 1.15. 1.15, I think, is an incredibly exciting release. We just packed so much into it all. And so, for me, I think the most exciting part of 1.15 is the fact that workflows are going stable. So with that, let's hand it over to Jeroen, and he'll dive into some of the amazing feature work we're doing inside there.
Awesome. So I am going to talk about workflows going stable in 1.15, and I'm going to cover some of the improvements we've actually made along the way, especially in 1.14, because we've introduced something called the scheduler service in 1.14 that is extremely important. Also in 1.15, since it's going to be the default way where in how Dapr actually orchestrates all of its reminders, logic for actors, and subsequently workflows too. All right, so just a short primer about workflows. What is a workflow? Well, Dapr workflows essentially allows you to execute business logic in a durable way, meaning if you have any sort of activity, which can be sequential or be running in the parallel, Dapr will make sure that it runs to completion, that it's stateful, that if any step fails, it will actually rehydrate the state and continue where it left off. So imagine you wake up in the morning and you have your routine, whatever that may be. You might go to the bathroom and brush your teeth and then drink coffee and then go to work. If something interrupted you during each one of these steps, you essentially don't want to have to start all over again. Like you don't have to, take a shower, for example, if someone interrupted your morning coffee. And so this is exactly what workflows will do. It will save the state of each one of those steps and allow you to even go off of your routine and create child workflows and then merge back into your main workflow. And you can start off with the history of your previous workflow, or you can start a new one. So it's a very, very powerful programming model that really can be used from a lot of languages. So we have supported for C#, Java, Python, JavaScript, and actually Rust too, I believe. And it's also coming to PHP. We have a Dapr maintainer who's back from a long vacation, and he's now writing Dapr workflows for PHP. So it's going to be very interesting to see how Dapr workflows meets the web. So really excited for that. We're going to go over the patterns in just a sec, but there's a lot you can do. Fan in, fan outs, waiting for external events, sequential workflows. We'll cover that in a second. And it's a pretty great fit for data processing, AI agentic workloads, which is an interesting scenario that we're seeing coming up more and more recently. Just to be able to treat multi-agent workloads as essentially, workflows that have their own state. Business orchestration, as I said, it's a very general purpose programming model, and a lot more. So here's a workflow example. You start the workflow, and that might happen due to an HTTP request. It might just be a console application that you kicked off. It can really be anything, or it can be a message that you receive. Now, anything that you see here can be done through other Dapr APIs or not. So for example, when you receive a message, you could just start a Dapr workflow based on a Kafka event that you receive with the Kafka SDK, or you could use the Dapr Kafka PubSub API. And then you kick off an activity that gets a secret. Now you want to wait for some external event. This might be human interaction or human in the loop, or even an AI agent that's doing a job, and then signaling back that's done. And then you essentially continue on to execute two other activities in parallel. You can execute two, or we also support thousands of activities in parallel. That's one of the great improvements we did in Dapr 1.15 that we'll cover in a sec, where the scalability of the actual workflow engine has improved by a lot. And then, in this case, one of the activities, activity B in this case, can store the event result in a database. You can do it through your client SDK or through the Dapr API. It's all up to you. And then activity C just invokes an external API, which can be a gRPC API, just an API gateway, whatever you want. And then we take that data and we aggregate the results into another activity, which then publishes a message. And again, this can be done through Dapr, or just using a client SDK that you own and control. And that's the end. So if any one of those activities were to fail, Dapr would essentially pick up on the last activity that was successful, it would rehydrate the state, and then just drive the state back to the activity that's now retrying, and then pick off where it left off. So task chaining is one pattern that you can achieve. This is fairly simple. You have a sequential activity where you want to ensure that these multiple activities are executed in order and in succession. And the order of execution is very, very important here. You want to make sure that activity A never happens before activity B or activity C, and you can take the output from one activity and just use it as the input for the next one. Fan in, fan out, a very, very MapReduce-like pattern where you can essentially kick off a lot of activities, only this is not requiring you to, unlike MapReduce, write data to disk and rehydrate the state yourself. The data can actually flow between those activities, and these can be executed simultaneously. So you can achieve a lot of parallelism here, and then essentially take the results and aggregate them and continue the workflow. You can kick off another fan in, fan out activity, or you can just hand that result over to a sequential workflow. It's up to you. Monitor is a nice pattern where you essentially want to kick off a recurring activity. This is kind of like the Kubernetes API server. If you look at it from an architectural perspective, it's used periodically to check the status of something, do something, and then return the status to the process that initiated the check. So this is a reconciliation loop. For example, Kubernetes looks at the etcd server every once in a while, and then brings the result back to a watcher, which is an SDK that puts a watch, and then you can take that state, perform actions on it, and the loop will continue reconciliation. So you can write something like that yourself without needing to talk to etcd or the Kubernetes API server in just a few lines of code. So this is a very, very nice pattern to implement, and it's it has a lot of use cases. External system interaction. This is where you want to involve some sort of an external event or a signal that should halt the workflow, maybe even in months or years until some event has been raised. So you want to get an approval, and that may be a call to an external system, and then after that you wait for an event, an approval event. As I said earlier, it can come from a machine or it can come from a human. And then once it's approved, you can just continue on to the next step of the workflow. Yep. So this is essentially how the workflow engine works. The workflow engine is inside Dapr itself. There is no other dependency other than Dapr sidecar and a control plane service that we use for scheduling, which I'm going to cover in the next slide. You have your application here on the left. It contains the workflow activity and definition. You have the Dapr instance, that's Dapr D process, can run on a VM or on Kubernetes inside of pod that schedules the activity, and Dapr essentially keeps the history state of the workflow and its sub-activities in an append-only state store. So it uses event sourcing to achieve all of that, and that's the right pattern that we do. You as a user, you don't need to care about the underlying database, writing to it, querying it, or the event sourcing itself. Dapr takes care of all of that. The only thing you need to do is use a workflow SDK to basically author it, and it's very natural looking. I'm going to show you that in just a second. And essentially you schedule activities, and Dapr through a gRPC stream will invoke the app again. So a lot of Dapr APIs require you, well, maybe not a lot, like PubSub and bindings, they require you to start a port to get results back from Dapr. But workflows is all gRPC BiDi stream-based, or client streaming-based, I should say. So you don't have to open any port in your application to use Dapr workflows. It's all one way into Dapr, and then Dapr will just call back into your application via gRPC streams. Dapr workflow engine is built on top of Dapr Actors. So Dapr Actors is a really great way to distribute compute and state together at scale, really useful for things like IoT and gaming sessions. And it's also a great low-level building block for things like workflows, because each activity can actually be modeled as an actor. And also the workflow itself, which is what we have here as the orchestrator actor, can also be modeled as an actor. And then there is state, and since each one of these are actors, you do not get conflict inside of the database, because each workflow has its own unique ID, and each activity has its own unique ID, and so they're only mutating their own state, which is great. So moving forward in Dapr 1.15, we are making stable something called the scheduler service, which you see here on the right. It's currently in beta in Dapr 1.14, or preview, I should say, meaning it's not being meant to be used in production, but in 1.15, this is going to become the default. And what this does is we have a cron API that is essentially being used by just users directly, and also by workflows itself. And the Dapr sidecar essentially opens persistent streams against a leader. What do I mean by a leader? So there is a new control plane pod. If you do in 1.14 kubectl get pods dash in system, or just run Dapr locally using Dapr init, you will see the scheduler running on there. And that is essentially an embedded etcd that Dapr manages. So it's not an external etcd that you need to run, heaven forbid, no. etcd is written in Go, Dapr is written in Go, and so it was very easy for us to just embed etcd inside of a Dapr Go binary, which is a new control plane service. Dapr has full control of how it does log trimming, how it handles the state and cleanup of the etcd server, so you don't have to do any of that. Dapr has very strict requirements in what it needs to do when it manages etcd state behind the scenes, so it just does the right thing for you. And from a management perspective, there's not much you need to do other than, if you're, for example, running Kubernetes, bring in a volume to serve as the disk. And then you also have a bring your own state store, which it's actually not quite optional. That text should be going there, but we've actually taken we've offloaded a lot of the responsibility that the state store used to hold, and we've moved that to the scheduler service itself. Which means it will be much more cost effective if you're using things like DynamoDB in AWS, or Cosmos DB or GCP Firestore as your workflow state store, because there will be less data going into the user-based state store, and a lot of that is just no uploading to etcd, which is disk-based, so costs should go down. All right, what are some other scalability and performance improvements we've made? Well, in Dapr 1.14, a workflow was hard-coded to run for a maximum of 1 hour, which was extremely limiting. But in 1.15, you will be able to run workflows for infinity, essentially, and we will be looking to introduce user configurable timeouts from the SDK. Some of them already support that, others need to have that embedded in them, or you'll be able to control for how long the actual workflow runs. Also, workflow pods can now be scaled horizontally. So in Dapr 1.14, without scheduler service, you could really only have one instance of your pod that hosts the workflow. If you try to scale out to more than one instance, you might have been seeing issues and errors, and workflows would just not run into completion. But beginning 1.15, you should be able to scale those out horizontally to hundreds and even thousands of pods. And also, activities will be able to support more than 100 steps. This is for some state stores, I should add. State stores like DynamoDB and Cosmos DB and GCP Firestore have transactional limits where only 100 items can be inserted in a single transaction. So we've kind of like had to work on chunking. This is work that's actually still being done for Dapr 1.15, but when we launch, you will be able to use these serverless databases together with workflows to achieve that and not see any throttling issues or anything like that coming from the Dapr workflow engine. You will also see reduced memory overhead. This is specifically also for 1.15, because in 1.15, we're moving away from JSON serialization to native proto-serialization across all of our stack. And this helps not only improve throughput, but more importantly, reduce memory overhead. And if you reduce memory overhead, then you're just going to be more cost effective on your infrastructure costs, especially as you run at scale. So the economy of scale, of course, improves as you scale. This is how it's supposed to work. All right, let's just see a very short demo for some perf improvements we've made specifically for scheduler service. This is actually Go code that I'm running here. Nothing too special. Here I'm registering a workflow. Let me just zoom in a little here. Registering an activity, starting the workflow engine. I have my workflow client that's initializing, waiting 3 seconds just to give Dapr some time to initialize. And then this essentially runs a scheduled new workflow, and it exits after 5 seconds. And then we calculate the number of scheduled workflows per second. So this is not about how many workflows can actually run per second. This is how long it takes. It's really a latency and throughput test for how many workflows you can actually start. And we're going to be comparing before and after scheduler services enabled. So this is the test workflow. I call it test workflow 10. It has 2 activities in it. This is a sequential activity where we call an activity, we await, we take the input, we kick it off to a separate activity. And this is just the activity itself. So some string manipulation here for the input. Yeah, so fairly simple. And I have my state store inside here. It's using Redis, nothing too special, just Redis running as a Docker container on my machine. I have config running here. Scheduler reminders is false, so I'm not using scheduler right now. And let's run this. We might actually even be seeing some errors because that's a state in 1.14. So yeah, I think let's run this. This is a Dapr CLI command. This just runs the Dapr sidecar and my Go application side by side. Okay, yeah, and it finished, and we can see that we orchestrated 154 activities. These errors happen because we just abruptly kill the app here and Dapr. We don't give it time to error out. So 154 workflows per second were started. Now I'm going to go back into here and do schedule reminders true, and I'm just going to kick this off again. And we should be seeing an improvement. All right, so this is going to run for about 5 seconds. And we can see that now we've executed 435%. This is roughly 150% increase in throughput when using scheduler reminders or not. And in Dapr 1.15, there's additional performance improvements, the ones I've mentioned earlier, and we will be releasing specific benchmarks, just like we do for service invocation today for workflows too.
All right. I think we should do another session. And with us is Cassie, and she'll talk about the Jobs API, which is still fairly new, and the scheduler service. So welcome, Cassie.
Alrighty, yeah, let's get into it. Let's talk about the Jobs API and scheduler service. My name is Cassie Coyle, software engineer here at Diagrid on the open source team. I'll do a bit of a brief motivation for why we initially introduced the Jobs API and the scheduler service. As we know, we had the cron binding in Dapr, but we wanted to enable more flexibility since it was so popular and extend that to have a first-class, API. So we have the Jobs API. You can do, schedule recurring tasks with it, such as automating your database backups, email notifications, maintenance tasks, and so forth. And then, as Yaron has mentioned, we wanted to increase and improve that scale for actor reminders. So actor reminders are a thing that would tell an actor when to come back online again. And it didn't really scale as well as we had hoped. So with workflows using actor reminders under the hood, we also saw some scale issues there. So now with the scheduler, we'll increase and improve that scale for, the actor reminders and then therefore workflows. The scheduler was introduced in Dapr version 1.14. It is now going stable in Dapr version 1.15. And it's deployed by default, with a Dapr init. It runs in a single instance and in HA mode, runs in Kubernetes and in standalone mode. And it is just responsible for, storing those jobs to be triggered at some point in the future while guaranteeing that, a single scheduler instance is going to trigger back one job. So you don't have to worry about multiple schedulers firing back the same job because we have logic to handle that. And implementation-wise, it includes an embedded etcd database, and it has a cron scheduling library. All of that is bundled into one scheduler process. With the scheduler going stable in this release, Dapr version 1.15, we have ensured stability and added all of these features here to make sure that it is stable. So some of the metrics we added were how many sidecars are connected, the jobs created total, jobs triggered total, and then of course the trigger latency. We enabled scaling the scheduler independent of the global HA flag. So there is now a scheduler HA flag, so you can scale it separately of the global HA flag if you so choose to. And then with the ephemeral storage, so we are disallowing running scheduler with ephemeral storage when running in HA mode. This was to fix the member has already been bootstrapped error that we were seeing with etcd, such that like when you had 3 schedulers and one instance went down, it would try to come back up and then just throw that error out. So now to fix it, you must use a persistent storage when using HA mode, and then you cannot use the ephemeral storage with HA mode. For the scheduler, we also added the failure policy. So we have a same default, which is a consistent retry with a default of 1 second delay, and then it's going to retry 3 times max. You can optionally, drop a job if you so choose to. That's fine as well. And then those are for like client side issues. If there are non-client side issues, like if a sidecar goes down entirely and there are jobs in the scheduler that are, trying to get fired back, but that sidecar is down, we don't want to do that. So those will live in a staging queue such that when the sidecar comes back up, we will send them along. And then we also have a Kubernetes namespace controller. As the name suggests, this is for Kubernetes mode. For whenever you go ahead and delete a namespace in Kubernetes, we are going to purge and clean up all of the jobs for that namespace. This is to, have cleanup in our etcd to not have that unnecessary space wasted, and then also to prevent the additional resource consumption. Then we are enabling dynamic leadership of our internal cron library. This is really to ensure the next bullet, which is making sure that the Dapr sidecars have a dynamic list of active schedulers. When we brought up the scheduler in 1.14, it was just a static list, but then users were seeing an issue when a scheduler would go down and the sidecar was still watching for that address, like watching for jobs, and it would throw out an error, like watching jobs. So now with the dynamic leadership, upon startup, a scheduler will announce its host and port to the cron library that will then live in the leadership namespace or like key space. We have a watcher on that. So when there is a change in leadership, we will then send along to the sidecars on a watch host endpoint the active list of the scheduler addresses and restart the connections such that it'll fix that issues or the issue users we're seeing. And not on here, but we will be adding MTLS between the etcd instances as well. And then again, ensuring that stability, we have a fully comprehensive and well-defined end-to-end test suite, as well as a long-haul test suite. And this is testing jobs of all kinds, jobs from the Jobs API, from actor reminders, and then with using workflows, which of course uses actor reminders under the hood. And Yaron had mentioned this, but active reminders are going to default to the scheduler service as of Dapr version 1.15. This is because the scheduler service is stable and it enables the scalability of the active reminders and workflows. So yeah, default is true. You can see the configuration setting there on the right. You can optionally disable it if you don't want to scale for whatever reason. You can set it to false, but it will default to true. With this, when you upgrade, we're going to auto migrate your old reminders into the scheduler service to provide a seamless experience and no loss of reminders. The Jobs API is still in Alpha API. It is not going stable this release. With it, though, you can still schedule get delete jobs, and it's now supported in the Go SDK, .NET SDK, and then it's almost there in the Java SDK. We have a PR open for it currently. Same goes with the metrics. We have an open PR for metrics that we're hoping to get in for 1.15 that will add metrics for the job trigger success count, job failure, or job trigger failure count, sorry, and then the job latency to trigger. And here's how it looks to use the Jobs API with the Go SDK. I took out the rest of the app code, but you have server.add job event handler, passing in, of course, the job name, and then that handler func, or like the function you want called back and like executed at trigger time. And then that's how you would schedule a job, get a job, and delete a job. Here is the equivalent code for .NET, where you would set a handler and then schedule a job. So you see app.map Dapr schedule job handler, give it a name, some details, and so forth. Then at the bottom, we have that schedule job call where it's saying await Dapr jobs client schedule job async. The Jobs API and the scheduler service work seamlessly together for this experience. You can schedule jobs to be executed at some point in the future, to go execute business logic for whatever purpose you see fit. Your app would schedule a job, it'll go to Dapr, and then from there, it gets sent to the scheduler. It'll live inside that embedded etcd database. The cron library is doing its magic. At trigger time, the job is then sent on a streaming endpoint via watch jobs to the sidecar. Then the sidecar sends it back on the on-job event endpoint or /job, unless you're using an SDK and you registered like your handler func. Alrighty, so key takeaways. The Jobs API is used for scheduling those future tasks. It is an alpha API still. The scheduler service is now stable for Dapr version 1.15. where it improves the scale for the actor reminders and workflows. And because of that, actor reminders will now default to the scheduler service. And then here are some links. I wrote a blog post on the scheduler service and the Jobs API. I did a demo in a prior community call. Those are links for the example code and then the long haul apps if y'all want to take a look. And then, the overview and a quick start example.
Perfect. I think you did mention it already, but do we need to do something special regarding the reminders if you have it in 1.14 when going to 1.15?
No, yeah. So when you upgrade from version 1.14 to version 1.15, it will be a seamless experience. You do not need to migrate the reminders yourself. We will auto create them. And then we do not auto migrate back. So if you want to downgrade, we do not auto migrate going back. So just heads up.
Yeah, it's a one way. Okay, that's good to know. All right.
The other thing, you've also introduced an HA mode now for the scheduler service, yes?
That was there in version 1.14 as well. Yeah, so scheduler runs as a single instance or as 3.
Nice.
And typically that's the recommendation that we have when we run it in production, yes? So when you run it on a Kubernetes environment through your Helm chart, always deploy via HA mode, yes?
Yes, that is correct. And you'll have persistent storage as well to not have any loss.
Thanks so much, Cassie.
Well, next up we have Elena, and she's going to be talking about streaming subscriptions. For me, this is one of my personal favorites. I think, the way we have pub/sub messaging today is an incredible feature inside Dapr, and I think streaming subscriptions really kind of transforms the ease of use of this. So let's dive into it now, and Elena, over to you.
So my name is Elena Kolowska. I'm part of the open source team at Diagrid, and I'm usually spend most of my time working on Dapr core and on the Python SDK. Today, we're gonna do a little quick presentation about the streaming subscriptions in Python that we are introducing in 1.15. So we're bringing this feature to the Python SDK now in 1.15, although the bidirectional streaming in the core product in Dapr was introduced in 1.14. And if you were here in the last call, in the celebration call for 1.14, you probably remember Josh explaining this feature very eloquently. Okay, so how does regular streaming work right now in Python? If we have two applications, publisher and subscriber, Daprized, obviously. We have the publisher pinging the Dapr API to publish messages. The Dapr then sends messages to the broker. The other Dapr, the subscriber Dapr instance, gets the messages from the broker, from the topic, and then it needs a way to send those messages to the subscriber application. So in order for that to be possible, the subscriber with regular PubSub has to have some kind of server that exposes an endpoint to the Dapr sidecar. And maybe that's easy, like if your subscriber is already some kind of server, maybe you can just easily add an HTTP endpoint or a gRPC one, but if it's not, then it can be a little bit bothersome, you know, okay, I have to start a server just to be able to receive these messages. And even though the Python SDK provides this extension like gRPC app as extension where you can very easily start a gRPC server and register your handlers, it's still maybe not the best developer experience. We try to make it as easy as possible, but we can do it better. So this is how the code would look for the regular PubSub. You would import the gRPC extension, start an app, and then register a handler with this subscribe decorator, specify the topic name PubSub, and then you do your job in this handler, return a specified response, and that's basically it. Okay, so then why do we need bidirectional streaming? Well, bidirectional streaming works on top of gRPC streams that work on top of HTTP2. So it just makes use of the more optimized, so resource optimization and message handling on HTTP2. So then that gives us lower latency, that gives us higher throughput, because you're going to be like less overhead, right? Of data, we're going to get a better cost efficiency because we are moving less data across the network. So all of that is great. And the last one is probably my favorite, and it's right up Dapr's alley. It just gives us a better developer experience because you don't need to be running any server on your subscriber side. You can simply create a stream and use that stream to make your application, let's say, contactable by the Dapr sidecar. So how does that look? Very similar to the previous architecture, except we've lost that server here. So now there is a bidirectional stream between the subscriber and the Dapr sidecar, and this is how the messages are getting exchanged. In terms of code, very similar to what we had before, because the Python SDK tries to hide all the complexity from you. So on your side, you can simply call the subscribe bit handler or purely subscribe method. We have examples for both, and this is just syntactic triggers, so you don't have to write a lot of code. So you can create a handler that's going to receive the message. You can do your processing logic in here, and you can send the responses. It's success, retry, drop. Okay, and that's basically it. Then you get back a cancel function or closing function that you should call when your application exits. And that's it. That's all of the code that you need to do in order to be able to use bidirectional streaming. So with this, you don't have to, like, one big benefit is that you don't have to open ports on your server to be able to run a server, then open endpoints and be contactable from the outside. That's one big deal here. I was curious, this was fun when I started working on it. So I actually did a little benchmarking, very unofficial. This only ran on my computer, not some isolated environment. So, I mean, I couldn't guarantee that, like, what was the CPU load on my computer like. But just with like a few quick measurements, I was able to get these nice results. So the yellow bars are streaming PubSub, regular PubSub are the blue bars. With regular, like for different number of messages, this is 10,000 up to 1,000,000 messages. We got different throughput. So for regular PubSub, we were very oscillating around 4,200, something like that, in terms of throughput, messages per second that the app was able to process. And for streaming PubSub, we were oscillating more like over 5,000 messages per second. So benefits of something like between 12 and 30% better throughput. Although again, you see, I mean, this is the variation is not small here. Of course, this is going to depend on the load that I had on my CPU at that moment. Okay, let's do a very quick demo. I'm going to use Dapr Diagrid conductor to show this little demo I have. So we have a publisher app, we have a subscriber, a regular subscriber, and a streaming subscriber here, running in a kind cluster on my local host. And then if we look at the publisher, we isolate this, and we can see the my pub/sub component. This is the Redis component that's in the middle. So the publisher sends to the Redis topic, and then from there the messages go to the regular subscriber and the streaming subscriber. So if we go and maybe see some metrics here, we can see on the pardon, let's go back to the apps. On the regular subscriber, we can see gRPC calls happening, right? So there we can see the latency, we can see the throughput, because we have that gRPC server running to receive the messages from the sidecar. And then if we go in streaming subscriber, there's no metrics, no gRPC metrics, nothing's running. All the messages get passed around just through the stream, not the screen. Okay, so that's it. That's the demo. I can show you the code a little bit. So you can find the demo on this link. So under the Diagrid Labs organization, streaming and pub/sub Python. In here, you can see we have the publisher is a Go app, very simple one. I try to keep the code focused only on more of a teaching purpose here than correctness. And then regular pub/sub, and let's look again at the streaming pub/sub here, where we have the code that I showed you before. Here's the handler, and then we, this is the main loop that we run. You can check the README file. You can run this demo locally. There's detailed instructions, or you can run it in a kind cluster. For that, you can use the setup script I prepared for you, and you can set all of this up. You can subscribe for a conductor account if you also want to see these nice visualizations here. And that's it. Let's just do a little takeaways and Q&A if we have time for that. So we have now bidirectional streaming for Python, .NET, Java, and Go in like the four, let's say, main SDKs. A key reason why you would like to use streaming pub/sub over regular pub/sub is if you don't want to run an extra server on your application and like not opening any extra ports for that. And you can get slightly but meaningfully better throughput. That's it. You can see the docs here specify, you can find them on the Dapr docs website. And that's all. Do we have any questions?
Yeah, we have a question of whether there's any C# examples inside here. I think we will be putting some C# examples in for this pub/sub streaming into the .NET SDK, isn't that? I think that's correct.
So if there's, maybe I can reveal a little trick that I use. if I can't find anything straight in the docs, I usually go to I will do something like this.
It's okay. Actually, Wit has posted an example of this. So yes, there are some. Yeah. What I know about
SDK
this
basically has an examples. Every SDK has an examples directory where you can go ahead and find a lot of examples. That's the trick.
Yeah. What I love about streaming subscriptions is that it's very dynamic. So you can actually create them on the fly. Isn't that correct?
Yes, exactly. Yeah. You don't have to like specify configurations like with regular.
Yeah, I'll just want to add two major benefits for this API. One of them is, of course, that you don't have to open a web server anymore, which is very, very convenient for developers. And the other one is that you can actually control back pressure, because if you think about it, this really allows you to have a pull-based approach, not like the push-based approach that Dapr had up until now. So if Dapr just pushes messages to your application, there isn't a really convenient way to tell Dapr, hey, I'm busy, just hold off a little. with a pull-based model where you can actually iterate and consume messages, you're free to basically deal with back pressure. So you can take 5 messages, process them. Once you're ready, process the 5 next ones. So this is extremely good for latency sensitive or performance sensitive operations.
And so this is going to be really the preferred way of consuming pub/sub messages.
Yeah, in my view, yes, definitely. Unless you're working in some sort of serverless environment where you scale down 0 based on incoming HTTP events, and so you don't want to have the process sitting and just listening to the gRPC stream the whole time. Otherwise, yes, it's definitely the preferred model.
Yeah, and in fact, going back to your back pressure comment, is that Waldo, who's a .NET maintainer, says it's worth mentioning that in the .NET SDK, he accommodates for the back pressure, so you literally just have to consume the messages.
Awesome. That's great.
Amazing demos, amazing features. It's great to see this across all of the SDKs now. I think in the 1.14, we only had this in the Go SDK, and now you've got it in Java, .NET, Python, and in the C# one. So it's amazing to see it all. So it's great. We now encourage everyone to sort of try this out and kind of start using it.
Really cool. Thank you so much, Elena. Yeah. Now, in general, that's also really what I like about Dapr, right? So Dapr itself is also evolving, right? And yeah, we find better ways for like a better developer experience. So it's nice that this is now an extra option to provide with pop-up messaging. So really cool. All right, I'm gonna quickly share my screen again to announce the next speaker, and that's Alice, and she will talk about error codes in metrics.
Cool. Welcome. So yes, as Mark mentioned, I'm going to discuss the error codes that we have in Dapr, as well as the new feature which allows enabling metrics for those within the runtime. My name's Alice Gibbons. I'm head of customer success here at Diagrid, and I usually spend my time talking to users about Dapr, which is what I'm doing right now. So it makes sense. So kind of wanted to set the stage in terms of error codes. I'm fairly sure, most people are familiar with HTTP status codes, things like 404 unauthorized or not found and, unauthorized. But an error code in general is just a numeric or alphanumeric code that indicates the nature of an error and, when possible, why it occurred. So in Dapr, this is taken to the Dapr runtime in particular. These are standardized strings for over 80 plus common errors. And this is across HTTP and gRPC requests that are made to the Dapr runtime. The error codes themselves were first introduced a few releases ago. I believe it was like 1.12 or something, but we have made a bunch of improvements on top of error codes themselves, on top of the standardization, as well as added metrics to them in 1.15. They are returned in the JSON response body of the request typically, and you can also see a lot of these error codes logged in the debug log level of the runtime. So if you're running in Kubernetes, that would be like the sidecar, or if you're running in self-hosted mode, you could see that if you're running debug logs. So this like standardized view of error codes has 3 parts. It has the prefix, it has the category, and then the error itself. So, the prefix always has that ERR underscore, and then the category, which is particular to the specific API that the error code is happening in, and then the actual error. So this one is super common. Maybe you have misconfigured your pub/sub component within the runtime, and the Dapr runtime itself cannot find the message broker that you're reaching out to from within your code. There's a ton of different ones, like I said, 80 plus, and a lot of these are the most common errors that we see that are returned from Dapr. Things like actors, things like workflows, state store not being found, but then there also are some categories in terms of health and then common categories as well. So I just wanted to show quickly kind of what the error codes look like from within code. I'm going to switch over to VS Code just for a second here. I have a super simple Express application on the right. This is just showcasing, it's a fairly regular Dapr app. I'm taking a dependency on the SDK in this case. So, I'm using the JavaScript SDK, but that is not required for error codes to be shown. I also have a number of different API calls that are being exposed. So, as I said, this is an Express app. I'm exposing a couple routes for things like, getting the state. In this case, I'm getting the Dapr state from the state store. So what I'm doing is after the client instantiation, I'm calling the state get API onto a state store within my that's running locally here. And then similarly, I have another call to a Dapr binding. This is, taking advantage of the binding building block API. In this case, I'm trying to send a message to an output binding. Similarly, I'm querying state. And then last but not least, Dapr, I'm using publish and subscribe in this last call. So these are just like 4 common, API building blocks that you might want to take advantage of when you're developing your apps. And, to kind of prove that this application is in fact working, it isn't just like a fake app. It's going to run the sidecar locally. So again, I have Dapr instantiated on my machine. I have running in self-hosted mode. In this case, I'm actually just using Dapr 1.14. But, I'm also running a number of arguments that I'm passing into the Dapr CLI. So again, nothing crazy here. Essentially, I'm passing it like an application ID, an app port, all, args that you would need in order to kind of run Dapr on your machine, exposing the application or exposing the Dapr APIs via both HTTP and gRPC. That looks like it's working so far. I have a number of the sidecar logs running, but then I also can see that the application itself has started up, so that looks good. And then if I wanted to, try out this first API call here, I'm just going to try to get state from my local state store. So, this is working. That's good. I'm just using the REST client VS Code extension to actually send these API calls. And yeah, that's all good so far. So now say, I'm developing and maybe I accidentally like fat fingered the state store name within my application or something like that. Wanted to showcase an error that is very common when you're developing. So of course, if you are familiar with the Dapr APIs, you know that this name needs to match up with the actual component metadata name that you are loading into the Dapr runtime. So in this case, my application is looking for the state store named state store. In this case, it's pointing to a local Redis component that's running on my machine. But if within my code I accidentally had added an extra E or something like that. The same application call that I ran before, I'm going to get a much richer error. In this case, I'm getting an error code that shows me, hey, state store not found. It's going to send back the specific message, that's just from my application logic, but then it's also going to give me this, the reason in terms of like why the request didn't go through. So that's really good from a debugging perspective, because not only do I have, that insight, I can also head over to the Dapr docs and figure out, what this actually means from within the context of my app. Similarly, like if I had any other of these calls, if I wanted to try saving a message on an output binding, I'm going to get another one here. You can see error invoke output binding. This is one that is particular to when the name of the output binding cannot be found. So again, kind of similar to that state store one, and so on. So one other one I'll just show super quick here is if I wanted to invoke the query API. So this is an API that's not supported from within all of the different state stores. And you can see a very specific error code saying, hey, the state store you're using is not supported for this operation. So like from this perspective, what I could do is I could head over to the docs and I could actually get, this one's better. Like I could actually get some of these errors shown directly to me, and I could say, hey, this is actually referencing a state store that hasn't been found within the runtime, which would actually just help me figure out, on my application what's wrong, and kind of hopefully I can move forward a bit quicker. So that's kind of just what error codes are all up. If I flip over now to what's new within Dapr 1.15, so we've added what are called error code metrics. And so Dapr error code metrics, this actually is a new metric that's being like, you can scrape exactly the same way as you can all other Dapr metrics. So it is being, there's a Prometheus endpoint on each of the sidecars, and typically that is how most of the other Dapr metrics are collected. And there's a new metric here called error code total, and this actually counts the number of times an error code has been thrown for each application ID. By default, this is disabled today due to the fact that, like, for metrics not being collected, metric series not being necessary to be collected, we've left it disabled. But you have to enable it via a Dapr configuration file with record error codes true as the property. And these are collected on a per application basis. So, they're grouped by app, code, and category. So I kind of touched on, the categories before, but these categories would be things like all the different APIs would be a category, actor, workflow, secrets, etc. Then we also have categories for health, and then common other error codes that you might get from within the runtime. So yeah, again, this is all opt-in, but kind of gives you an additional idea into what might be going on within your system, because again, these are otherwise only available within the debug logs within your sidecar or within your runtime, and or within the application logs themselves. You'd have to be parsing those application logs for these error codes to otherwise figure out kind of what some of these errors from the runtime were. So I'm just going to showcase what this looks like just using actually Conductor. So this allows me to, if I click on this cluster, so I have deployed my application, so the one with all the errors, I've deployed it on Kubernetes. I have two applications that I care about here. Specifically, the one that we were just looking at was my Node app. So if I take a peek at that Node app and just kind of show you what's going on there, you're going to see there's a ton of errors, right? So not looking so good. And you can see I'm also printing out a ton of these Dapr error codes from within the logs, which is great. But again, not always something that I'm going to be able to like just come in and see right away. So the reason why we added this error code metrics was to be able to figure out when these are actually occurring from within the runtime. So if I head back to Conductor, I've connected this cluster to Diagrid Conductor. And this allows me to kind of get a better insight into what's going on within my system. So you can see I'm running the latest release candidate of 1.15 because that's when these error code metrics were added. And I have a number of applications running. So I actually have, this Node app and this Python app, and it's also showing me a couple of unresolved alerts that are happening within these apps. I can get a better look at this if I take a peek at the apps graph. The apps graph will actually render your applications and show how they're communicating. So I can see that my Python app is in fact invoking or sending, a Dapr invoke service invocation call to Node. And I have a number of these alerts firing for these, even though the app itself is healthy. So the pod status is healthy. I also have, there's a ton of red. There's a ton of red alerts going on. So I can also see things like, the Python app is invoking the Node app. I can see the error rate. I can see latency and throughput kind of going in between these calls. And then I can also see that a number of alerts are firing for the associated pub sub or for the Redis component that's running in my cluster. So this is just some additional insights you can get here. But if I wanted to take a peek at the actual error codes themselves, what we've added is within the application specific view. So as I mentioned, error codes are always app ID specific. And I can enable them via the configuration file. So I'll need to add a config that has this record error codes equals true under the metrics spec of the config file. So I've added that, and you can also see that as well just within the annotation. You can see I've added that config. So I attached it to my pod spec there. A number of other things is within the errors overview tab. Let me close that. There's also a number of these errors showing up. So these are all HTTP requests that the Python app is making to the Node app. So if you remember, I was like invoking a pub sub, I was invoking a binding, I was like getting some state back from that, and then I was like trying to use the query API on a state store that didn't have that operation. So these are all kind of showing up within Conductor here. And I can also see super clearly like what errors are actually occurring. So for instance, One of the ones was this pub sub forbidden. Pub sub forbidden is actually an access control feature within Dapr, and this allows you to specify which topics within the message broker can actually be published onto or subscribed to. And so what this is telling me is, well, within pub sub forbidden is that this error has been occurring at a rate, this rate, if I scroll down over the past few hours here. And same for a lot of these other ones, right? So state store not found, that's something that's going to give me a direct insight into, hey, I'm reaching out to a state store that has not been loaded by the associated sidecar, the Dapr D runtime there. Yeah, and so kind of just a good way to kind of see that within Dapr here. I can also filter on category, so I can see, all the different state ones that are going on within my system. And again, this is all specific to this specific application. It's all filtered by application ID in this case. So that's just a quick overview on error codes in 1.15. Again, yeah, this is only available in 1.15 going forward, and you do have to kind of scrape that metrics endpoint to get some of this additional data. And I guess that's kind of leading to the takeaways, on that point. So, we do have these error codes now available for, 80 plus common Dapr runtime errors. You can see these as debug logs within the runtime today, but then you also can enable this error code metrics via your configuration file starting in 1.15. And some of the stuff is still in PR, but I did add a couple of docs references as well.
Great. Thanks so much, Alice. It's good to see so many failures in a demo and it's still successful. Thanks for this demo. So I have a question about the error codes in general. So we have a couple of newish and very new APIs, right? So there's the jobs API, but also the new conversation API. Do we already have error codes for those?
Yeah, so error codes for the conversation API were actually built in when it was created. So we definitely have those, and the jobs ones are coming, I believe, hopefully in this next release, if not the one after, but they are being added and also standardized as each new API comes in, which is great.
Cool, excellent, right. And do we actually still need some help with some of the error messages? Because I can remember that a while ago we asked the community for some help actually implementing them in some of the SDKs.
Yeah, I think some of those issues are still open for sure. I'm not 100% sure, but
okay, I'll find out later, right?
And also, is there work, Alice, that we're going to be doing inside the SDKs to consume the error codes better? Is that something that's
the SDKs? Yeah, it should be pretty standard within the runtime. So for instance, I was using both, I guess I didn't show the Python app, but I was a Python application invoking a Node app, and within the Node SDK, for instance, you should be able to get that back within that response. For each of the SDKs should be like that. You can get it back in .NET as JSON, as Node as JSON. As long as you can get the JSON object that's returned, it should be pretty standard within the SDKs. Good question.
Right. Excellent. Thanks again, Alice.
Yeah, thank you.
Yeah, nice.
All right. So next up is Bilgen Ibriam talking about the resiliency policies with status codes.
Hello, everybody. My name is Bilgen Ibriam. I'm a product manager at Diagrid. And in this part of the webinar, I'll show you quickly, how to make your applications more resilient using some of the new features that are coming in Dapr 1.15 and some of the older ones. Just a sec. So when applications span multiple services, especially on dynamic environments such as Kubernetes, services can disappear for all kinds of reasons, and network calls can start hanging. And what works, perfectly fine locally can start failing in production. And Dapr resiliency features can address that. We'll see how Conductor can make configuring these resiliency configurations easier. And we will do that gradually by adding, timeout, retry, and if we have time, circuit breaker. So for this talk, I have prepared two apps. These are the well-known from the Hello Kubernetes quick start. We have the checkout app and the order processor. I have implemented them in in Java, the checkout app will basically pass the calls to the order processor, which simulates various kind of errors. I have deployed those locally on Minikube and installed Conductor so we can see what is happening. So if I go on the terminal, here is my log for the checkout app, and on the right-hand side, we have the order processor. I use Scaffold to deploy those on Minikube quickly. That's my local development setup. And at the bottom part of the screen, I have Hey, which is performing HTTP requests. So let's do a smoke test and see what just happened. So I used Hey just to send 100 requests, right? In 10 of them in 10 parallel threads with order ID 200. That basically makes the order processor to return 200. And we can see those 100 requests return back in around half a second, and all of those passed fine. But service might be overloaded, for all kind of reasons, and that can cause delay in the responses. So let's simulate that. The way to simulate that in this case would be if I send another order ID, and we'll see that in a sec. Like if I send order ID 10, I will show in the code what happens. In the code, you'll see that when the order ID is 10, roughly 10% of the requests now start getting delayed. They respond after 10 seconds, and the other 90% respond instantly. And the 100 requests just finished. As you see, they all passed. But in this case, those 100 requests took 20 seconds, right? And that's because only, as you see on the right-hand side, the order processor was simulating slow responses for some of the requests. And that's what caused such an increase in the timeout in this request. So the way to handle those would be to add a timeout. And how we do that in Dapr is we configure a resiliency policy with a timeout. Now, what we've added recently in Conductor is something called Resiliency Builder, where you can find it on the left-hand side in Conductor. And once you get there, it will guide you to create a valid Dapr resiliency policy. So let's create one. The first thing you have to do is give it a name. Like in this case, I call it checkout resiliency because I will apply it to checkout service. At this point, you can optionally select a cluster if you have a cluster connected to Conductor. And if you do that, that will help you to configure the resiliency policy easier later. For example, I can scope this resiliency policy to a namespace. I can scope it to specific app. In this case, I want it to be a scope to only to checkout service. And in the next step, I will configure the desired policies. In this case, we said, let's add a resiliency policy, a timeout policy. And then this one is the simplest one. All I have to do is set duration. Now, picking this value can be tricky. And one way you could do is, for example, in your performance or testing environment, if you run some kind of tests, you can come to App Graph and see what were the latencies, error rates for the last 1 hour. Here I have another bigger cluster with roughly 10 apps. And here, for example, I can see if I isolate an app, which means I focus on this service and its dependencies, I get a view of in 95 percentile of the latencies. And here I can, for example, pick what's a good timeout duration for my service. Now, if this 1 hour is not sufficient, you can always find more metrics with a longer period on the service summary page. For example, if you go to 24 hour and pick the operation, you can see what's the average latency. For this demo, right, I want to make sure that it runs quickly. So let's say I set a timeout of 100 milliseconds. Now, if I have a typo or something, you see the UI will prevent that. So it will make sure that the resiliency policy you are creating is valid, in addition to suggesting, what you can type. So 100 milliseconds, if I continue, I want to apply this policy only when I am calling the order processor. And you see I have a list of all the other apps from the cluster. Same applies for other components or actors in the cluster. And here we have our resiliency policy. It has set it to right namespace and right app names, etc. I can copy it to my source code, but what I'll do here is I will download it to my download folder. And let's see if I do OK, apply. I'll apply this to Kubernetes, and we'll see scaffold restarting my app in a few seconds. So with this resiliency policy set, I can perform the same request and see what happens. If I run the same request now, it actually finished faster. But the effect of that, the side effect of that was that roughly 10% of the requests timed out, and they returned 500. So how can we fix that? Requests may time out, for all kind of a reason. Network may be congested, the service might be overloaded, and if we retry that, we can fix the error. So let's go and see how we can do that. On the resiliency builder, if I go back to the policies, I want to add a retry policy. Here you can see more a bigger form with more fields. Now this form is dynamic because the possible options for these resiliency configurations are a bit more complex. For example, if I choose exponential, some of the fields and the default values change. In this case, I want to use a constant retry policy. Maybe retry it after 100 milliseconds, and don't retry it endlessly, but 5 times. So if I continue with that and I want to apply it again to the order processor, I want to apply both timeout and the retry policy. And ta-da, I have my updated policy. So let me clean the previous policy. Okay, delete from Kubernetes and from locally. I will download this one and apply. Thing with this applied, and I perform my request again. You can see now, actually, all the requests succeeded. So what happened is, even though some of those failed, they were retried, and overall, all the 100 requests succeeded much faster, right, in 1 second rather than 10. This is, all great. I think it's a great win, but not all failures, should be retried. And usually the type of the error often tells us whether something can be retried or not. So if we go back to the slides for a second, here are some, good starting points when you should retry or not certain operations. For example, for HTTP, typically 404 is not a good one to retry, because if the resource doesn't exist, there is no point in retrying, unless maybe you have some kind of a eventually consistent app and you're retrying until a resource appears there, right? A bad request means your request is invalid. So you have to change something in the request before trying it. Or if you are not authorized, again, there's no point in retrying with wrong credentials. But other HTTP errors, such as 503, 504, are typically transient errors, and they may recover. So these are usually good candidates to retry. Same for gRPC. gRPC has different kinds of status codes, but you can see some of these are good candidates for retries, others are not. But the caveat here is for all of these, you have to make sure that retry doesn't affect, is aligned with your business logic, your operation is idempotent, doesn't have side effects. And you can now use this kind of functionality with Dapr resiliency policy, and specifically with retries. With this new feature in Dapr 1.15, you can filter your retries based on the status codes, and it lets you do more granular control and specify when to apply a resilient retry. I have two examples here from the spec. The HTTP status code, that's a snippet used to specify which HTTP status codes to be retried. It is basically a list of status codes or ranges of codes, and everything else is ignored. Similarly, for gRPC, it's a list of gRPC status codes. So I'll say let's go back and try to apply some of these in the resiliency builder. So if I go back more, and rather than adding a new retry, I will recreate this one. We set 100 millisecond, 5 retries, and here you can see in the UI these new fields available. They're available only starting from Dapr 1.15, and this UI will prevent you from typing something that's not valid, but if you are doing something invalid, that will prevent your sidecar from starting up. Now, this demo, I'll use the simplest possible value, so only retry 500 error code. So if I continue, and let's apply this again to the same target. I want to apply all the policy we have so far, the timeout, the retry. And you can see this new field added. And I have to go to the same process to delete the previous values, download the new policy, and apply it. Luckily, my scaffold environment is super quick. The application is already up. So what I will do is I will send an order ID 500, and let's see if that is retried. So if I send 500, see it's taking some time, and all of the requests failed. That is because if you root when order ID is 500, it just says internal error, which is a typically good candidate for retrying, but it never recovers, right? And in the log, we can find that this request was retried up to 5 times, possibly. Let's see if I can find, okay, retrying in 100 milliseconds. You can see it found our timeout and retry policy. Actually, there is another way to see if this was retried or not. If I try 501, that shouldn't be retried, right? And I can see, for example, 501 succeeded in less than a second, whereas 500 was going up to 5 seconds, retrying up to 5 times, 100 milliseconds. And I think this is already, much better. But and last thing I want to add here is, while retries can help clients recover from transient failures, they can also make a bad situation even worse. For example, if the server is struggling to reply, doing more retries, it can make things worse. And the way to address that is typically to add a circuit breaker. And we can also do that here. So if I go to the component builder again, and say create a circuit breaker, now we see what are the possible values here. Now, one of the things that was done in 1.15 is document when a circuit breaker can be tripped, because all the possible values were not in the documentation. Here, some, I think, good values are like consecutive failures and total failures. Not sure when you would use a successful request to trip a circuit breaker and stop requests. But these are all the values. And here you can use a common expression language, and the UI, again, will validate that. Once a circuit breaker moves to an open state and it stops passing the request, the next thing is to decide how long that should continue, right? So input this demo, I can say like 30 seconds, and then how many requests to pass over to retry, to check if the service is back, if you want to reset all the internal states, etc. And I can basically continue, and let me just add. Now I can specify all the policies here and get the resiliency policy I was after. Now, for the sake of time, I will skip applying this and showing you how it works, but the demo application actually have an endpoint where you can simulate a service getting overloaded and failing for 10 seconds and then recovering on its own. So this is a good example of how to use a circuit breaker in your app. Now, once you have the resiliency policies, a good thing is actually to check how they perform. And in I think in 1.14 of Dapr, what was added is ability to expose some of these resiliency policy internal state. So if I go to the resiliency policies on this cluster, the checkout app has the policy. This is the policy I've been playing with. You can see it's been active. Let's pick a shorter time frame. Here I can see that start playing with the timeout and how many times per second this policy got activated and triggered. Same for retry, the different statuses of the circuit breaker. What we have done as part of this 1.15 is actually expose the circuit breaker internal state in conductor. So here you can see actually that this circuit breaker was, typically it's closed when it's passing all the requests. And for short period, it became open state. We cannot catch the half open one because that's lasted very little. But you can expose here and see if your circuit breaker is actually doing what it was supposed to do. And yeah, here in addition to these metrics, they also default alerts. So if you are not aware that your resiliency policies actually get activated, they do retries, and this is how the system recovers, you can get notifications for any of those events. So we have set up also some alerts. That brings us to final slide. So the takeaways, let's say, is try to identify your critical paths in your application and the latency error patterns. For that, you can use some of the graphs I showed you or some other tools to identify those. Then configure, timeouts, retries, even circuit breakers. You can use the resiliency builder for that purpose. It will guide you in creation of those easily. And then it's also important to monitor those and see how they perform and see if you have to change and optimize them. Here I have a few links, the blog post with the resiliency policy, the demo project, the proposal of the status codes, and a book I found really useful around creating a resilient distributed system from Sam Newman. It goes much deeper into retries, timeouts, circuit breakers. So it's a great book. That's all I got. Mark, do we have any questions?
That's a pretty comprehensive overview of everything. I think the patterns and practices about the identifying the best patterns and practices for when to use them and effectively is pretty important, actually. Because what we see today is that it's often you have to understand what the system is like. So the fact now we have sort of those filters and retries on the HTTP status codes and retrying those is pretty useful.
agree. I think resiliency in general is becoming much more powerful in Dapr, and we combine with metrics and the resiliency builder. It's now you can go to full circle, define, apply it, monitor, and improve it. That's been the goal.
And then there's visualizations of when the actual timeouts happen and things like that inside the metrics, inside Conductor. They seem pretty useful.
Yeah, exactly. Yeah, that's what I was about to say as well. It looks much more usable now. Indeed, actually creating them, the policies first, and then also seeing them in effect. That's really valuable. Much better developer experience there. Good to see. All right, thanks very much, Bilgin. So next up is the brand new conversation API with a .NET demo, and we'll start with Jeroen Schneider, and the demo will be done after that by Wallo. Welcome, Jeroen.
Okay, cool. So let's talk about conversational API new in Dapr 1.15. What is it? It's a brand new API in Dapr that is really geared towards tackling the complexity of interacting with multiple LLM providers at scale. So if you are a developer who is not necessarily a Python developer or a C++ developer and you don't have these native SDKs, or if you're a polyglot shop that just wants to focus on the prompt aspects of the interactions with LLMs, and you want to make sure that these are being done in a secure, reliable, and observable way, I think this API is a great entry point for you because it gives you one consistent API to talk to all of these underlying providers, and it has all of the Dapr benefits. So think about this API being paired with what Bilgin just showed you, which is a circuit breaker, right? Because a lot of API providers, for example, have API limits and tokens, and if you get throttled, you'll be given an error back. But using the Docker circuit breaker, for example, or retries, you can actually retry the prompts that are going in, so you don't have to handle all of the fault tolerance and resiliency aspects of integrating with LLMs in your code. You basically hand that off to Dapr. You can also use, for example, Dapr middleware to be able to authenticate requests before they actually hit the LLM, to make sure that only authenticated users carrying an authorization header, for example, can issue a prompt. And so Dapr really provides this really nice runtime around the LLM interaction, not just the API, but really also anything that comes with it. And something else that's pretty important is observability. So Dapr will issue, metrics like what we've seen, requests per second, error rates, throughput for your LLM interactions, which make these open user interactions pretty observable, and it connects to your backend systems, just Prometheus metrics and Dapr tracing as it is today. So we're launching with support for AWS Bedrock and all of its underlying models, OpenAI, Anthropic, Mistral, and Hugging Face. It's fairly easy to add other ones because we actually have LangChain rightly integrated into Dapr, into the component model, so it's very easy to add others. And Dapr also includes some pretty nice enterprise features from the get-go, specifically PII scrubbing and prompt caching. So PII scrubbing will allow you to obfuscate data going in and out of the LLM. So, usually you'll have a user just issuing a prompt. You don't control that prompt. You have no way to validate what's in it. And so if it contains any form of, social security number, credit card, name, email, and you want that not to go into the LLM, Dapr will essentially scrub the data before it actually hits the underlying LLM provider. And the same thing it does for data incoming from the LLM before it reaches the user. So for example, if you're using your own private model and it was trained on a data set that might have contained PII data, and you don't want that PII data to make its way back into the issuer of a prompt, then you can just enable the PII scrubbing on output data too. And of course, you can enable them both on inputs and outputs. Prompt caching is also really, really nice because it lowers costs and reduces latency. So for example, you might hear that some LLM providers do have prompt caching, but using the Dapr prompt caching is actually much better than using the LLM provider's one. And why is that? Let's say you are talking to Anthropic, which has prompt caching in beta, and you're using that from an AWS EC2 instance or Kubernetes, whatever, and you're calling that. So Anthropic, for example, or most of the other LLM providers actually, will charge you 50% of the initial cost if it's getting inserted into the cache, and then there will be still a network latency because Even if it's cached, you still need to have that network hop from your VPC all the way into the LLM provider's server, which is hosted outside of your VPC, and that'll incur network charges. If you're using Dapr, however, everything is cached locally inside of your cluster, inside of your pod, and so the latency is much faster, and you will not be paying the cost of inserting the data into the cache to begin with, and you will not be paying for the egress request going out of your VPC to the underlying provider server too. So this is pretty nice. This is essentially how it works. You have your application talking to Dapr. Dapr, on its behalf, talks to all of these APIs here on the right, and you can optionally enable prompt caching and sensitive data obfuscation. It's also nice to note that prompt caching works for all of the models here on the right, and so does sensitive data obfuscation. So there is no subset of components that are only supported for each one of these enterprise features. These enterprise features will work for whatever underlying model you actually use. And with that, I'm going to kick it off to Whit to demo that from the .NET SDK.
Hi, I'm Whit Waldo. I'm the CEO of Innovian. I'm one of the .NET maintainers. So we have a quick demo here. So first of all, you'll start by having your components describing how to actually connect to whichever endpoint it is that you're trying to use. Here I'll be demonstrating Anthropic. You can set it up just like any others, drop your API key in here or reference a secret store. Here I'm just using an environment variable, so pretty straightforward. The application itself, we're going to submit two queries. We're going to submit one that just says, please write a witty haiku about Dapr. And then otherwise, I have messed up some CSV input that will, it includes email addresses, it includes phone numbers, and will demonstrate the PII scrubbing. It will remove the email address and the phone number in what we send to Anthropic. And then, of course, it'll process it and send that back. How this is, of course, demonstrating the .NET SDK. There's a variation of this in the example project itself, but this has been modified a little bit for this demonstration. But otherwise, it's pretty straightforward. To use this client, you register it, you submit the messages to it using this method, and submit the payload to it, and we simply send that to Dapr, get the response back, and we're good to go. So we'll just go ahead and run this, and you'll see it loads up. It'll submit the requests. Right, we got one of them back, so great. We have a nice little haiku about Dapr demonstrating that. We've submitted the data set. One of my queries to it was to repeat the data set that it receives, then clean it up and return that as well. And so you can see that it has received an obfuscated data set. The email address and the phone number were excluded. And then, of course, it cleaned it up. And there you go.
Awesome stuff. Yeah, the API is really geared towards reducing the complexity, just making it easier to write applications targeting LLMs, especially if you're a polyglot shop where you want a single Dapr API instead of needing to rewrite the same logic with different SDKs. And then, of course, if you're an enterprise, you want to be able to apply cost control and security. And it's also a great fit for agentic AI systems, which is something we'll cover in a deep dive later with Dapr, because we're seeing members of our community just showing up with really interesting agentic AI systems. And so if you're using that from a workflow, for example, that orchestrates a multi-agent interaction, then it's also making it a whole lot less complex, because you don't need to actually put in your own special business logic. You're already using Dapr, you have the Dapr client, so it's very easy to just issue a prompt to the conversational API to get the response back.
Excellent. Yeah, it really looks super easy to use. Yeah, so well done with the components and with the SDK. Nice, very nice to see this, and I think a lot of people are very enthusiastic about this. So this is really great to see.
Yep.
All right, let's move on. Thank you very much both to you, Ron, and to you, Whit. All right, so the next thing is, well, how to get all of the new bits, right? If you want to try out the new 1.15 release. And as mentioned, the full regular 1.15 release is not out yet. That will probably still take like a few weeks, but you can definitely try and install the release candidates, and more of the release candidates will be released soon, also over the next few weeks. So you can keep trying and actually help us improve the 1.15 release. So if you're just running Dapr locally and you already have the Dapr CLI, because I imagine you're already using Dapr, then do a Dapr uninstall first. If you want to do like a complete uninstall, so also remove all of the containers that the Dapr installs, do a Dapr uninstall --all. Then do a Dapr init, but the init always takes the latest regular version, and the latest regular version is still 1.14.4 at the moment. So if you want to try out the RC, then you need to specify the runtime version flag. So in this case, Dapr init --runtime -version, and then 1.15 RC1. And then you can do Dapr -v to actually check what the installed version is, and more information here in the docs. And again, if this QR code gets you to the docs. So that's for locally and self-hosted. And then if you want to upgrade on Kubernetes, then it's definitely the easiest via Conductor Free. So please scan this QR code if you want to get it right now. There is a GIF here, but I actually want to show it live. So this is Conductor. This is one of the clusters where Dapr is installed. In this case, it's already running the latest RC, but you can still actually update Dapr or downgrade Dapr via this menu here. Update Dapr. Here you select which version you want to update or downgrade to. You then select if you want to upgrade or downgrade Dapr to all applications or just a subset of applications. And then here you see the generated Helm arguments here, and you can actually schedule when you want to when you want to have that update take place, and because your Dapr sidecars will restart, so they can actually pick a moment when you want to do that, and then you do confirm, and then it will be an upgrade.
And as new release candidates come out, we're going to make them available inside Conductor, yes? So
exactly. Yeah. So this is definitely the easiest way to install it using Kubernetes. Yep.
And so watch out for new release candidates as they happen. We try to kind of keep them at a regular pace. It kind of is based upon sort of fixing issues, discovering things, and normally we do several of them before we get to the final release. But what we want more than anything is feedback and trying them out. Now it's a great time to try it out. Now it's a great time to give feedback, particularly with things like workflow going stable. And inside Conductor as well, we have all those great features as well that Billiken showed in terms of building a resiliency builder and a component builder as well, that are also lined up with the release.
Yeah, and the best place to give feedback is the Dapr Discord, right? So if you're not on there, please join the Dapr Discord. There's a dedicated channel to give feedback about this release candidate. Yes, so so please enjoy at least this first release candidate of Dapr and give some feedback. As mentioned, there will be more release candidates, so please help us with testing those. And the best place, as I mentioned, is to join the Dapr Discord to give us feedback. Of course, if you have any questions, maybe about this webinar or about Dapr in general, this is the best place to ask your questions there, because most of the maintainers are there. Excellent. Well, I really enjoyed this celebration event, so I hope you did as well. And please say hi on the Dapr Discord. I would love to know how you're using Dapr. So if you can share it with me, please connect with me, and see you during the next launch week event.